Hello students, welcome to our uncle.
Good evening, sir.
Good evening.
Evening, sir.
Good evening everyone.
Good evening, sir. Good evening, sir.
Good evening.
सर मेरा एक डाउट है
Yes.
सर 1D के लिए एवरेज वेलोसिटी 0 होती है ना
Yes.
बट सर आपने जो n डायमेंशनल फार्मूले से तो √2 kT upon pi m आई थी
बेटा आपने लेक्चर अटेंड करा था?
यस सर कल
But I explained it there only that it is mod of Vx average. It is not Vx average. मैंने लिखा भी होगा वहां पे, चेक करिए. It is mod of Vx average, not Vx average. Happy Janmashtami to all of you. Got it?
Thank you, sir.
यस सर यस
It was mod of Vx average. This thing, not this thing. This is always 0. No problem with that formula. Okay?
ओके सर
This was the only doubt.
यस सर
So kindly keep noting the things that I'm explaining in the class. I explained it yesterday also, I think. And we have derived this formula earlier also for mod of Vx. You can match that formula with the formula that we derived earlier for mod of Vx average. That is the same value we are getting over here for n dimensional. So let us continue. 3-4 questions are there on Maxwell distribution. So let us discuss them first. Consider a Maxwellian. Consider a Maxwellian distribution of the velocity because only for mod x that integral will be an even function. Na? The trick lies over there. If it is Vx only, then obviously it will be 0 because the integrand will become odd function. Because the limits are from minus infinity to infinity. Okay?
यस सर
You have to calculate the magnitude of this ratio. Of course, ratio because both are positive. Answer only in chat box, okay? Don't speak, so that everyone get the chance to solve the question. Very good, Siddesh. Very good, Sanju. Yes, Arun, away. Very good. Very good, Rima. Very good, Tamya. Very good, Kapil. No, Divya, it's incorrect. Very good, Ritika, Rita. Very good, Ishta. Very good, Prachi, Divya. Okay, so the answer is option C because we have to get this ratio, and most probable you know it is 2 kT by m. RMS is 3 kT by m. So 2 by 3 square. Okay, so this is the answer. Next one. Electrons mass m in a thin long wire Very good, Siddesh, Rita, Uzma, Ritika, Divya, very good. Very good, Kapil, Mamta, Abe, Arun, Tamya, Rishita. Very good, everyone. It's wrong, Prachi. Very good, Sanju. So see, the answer is 0 because it is 1D case in a thin long wire. Okay, thin long wire. So it is 1D, and we know for 1D case most probable and average is 0. It is VRMS, which is 2 kT by M. Okay, Prachi, it is not most probable. Clear?
Yes, sir.
सर VRMS तो KT अपन M होगा ना बनने के लिए.
Whatever, it was kT by M square root. Yes, I mean to say both of V average and V most probable is 0. Because Prachi, she said it's option B. Only VRMS is non-zero. That's what I'm saying.
Yes, sir.
All other are 0. Okay.
Okay, sir.
So for temperature, probability distribution. So they are representing probability distribution by the symbol F. Obviously, it is a function of V. And there are some graphs given as options. So you have to identify the correct one. How the graph it differs at different temperatures for 3D case. So A option is T2, T1, F of V, V, F of V. Please let me know when you have noted so that I can make the other graphs on the next slide.
Yes, sir.
Noted, sir. These are the options.
So for the option D, the peak of the two graphs were same, huh?
Yes,
Same height. Okay.
yes, same height. Uzma and Prachi, T1 is greater than T2. It's wrong. Uzma and Prachi, your answer is wrong. And what about yes, Divya, it's correct. Sanju, it's wrong. Abe, it's wrong. T1 greater than T2. Now let me check. Okay, T1 is greater than T2. So I'm thinking about T1 greater than T2. So let me check. So it's correct actually. So because T1 is greater than T2, so Uzma Prachi is correct. C option is correct. Those who have given the answer as C, it is correct. Because it is other way around, T1 greater than T2. I thought T2 is greater than T1. Okay, so those with answer C, their answer is correct. But some of the students, they are answering me B also. I don't know why. We have not seen this kind of graph. Never. So the only confusion could have been between A and C, because we made this kind of graph. And T1 is greater than T2. So at a greater temperature, we have seen that the curve was shifting towards right now. So obviously C option is correct. Revise the things every day, okay? This question was very easy. Straight away. Okay, next one. the average value of e power iota a dot p. This one. Average value of e power iota a dot p. And both of these are vectors. So it means this is actually three terms. E power iota ax px plus ay py plus az pz. And you can split that expression into three terms. E power iota ax px into e power iota ay py into e power iota az pz. That way. So you have to get three averages that way. Suppose A is ax I cap, ay j cap. Let me do the starting so that you can identify what you have to do. And p vector is px I cap, py j cap plus pz k cap. So a dot p is ax px, ay py, az pz. Okay, so e power iota a dot p means, therefore, e power iota a dot p means e power iota ax px, ay py, az pz. Okay. First of all, open the bracket. This. So e power iota a dot p average means average of these three expressions, isn't it?
Yes, sir.
So now how to find the average? This is just like finding the average. And now you know the formula. That Maxwell probability distribution PVDB formula. So it will be like m by, this term will be common in all these three, m by 2 by kt 3 by 2. And then it will be like minus infinity to infinity e power iota ax. Can I write it as mvx, px equal to mvx? Because the expression that I'm going to write, it is dependent upon the velocity, like this. Okay. So to show the dependence of px on vx, I have separated it as a product of m into v. Okay. And similarly, when we write e power iota ay mvy, it is like this, mvy square by 2 kt dvy, and minus infinity to infinity e power iota ay mvz, e power minus mvz square by 2 kt. Clear? Because I have used the normalized expression. I have taken care of this constant factor also. So that's why there is no need to divide that PVDV integral. Otherwise, you can. If you are dropping out this factor or you are not sure whether this factor was same or not, so then you can use that expression. Okay. So now you have to solve all these. So obviously, because all the integrals are similar, you can see this one is exactly like this one and this is exactly like this one. So it means the moment we are able to solve one integral, all the integrals, they will be having the same value. So we will just cube it out, the expression that we are getting. Okay. Clear? Please tell.
Yes, sir.
So now I have already given you a shortcut formula for solving this kind of integral. But first of all, you have to get this in that format. For e power minus v square, I have given you the formula. So first make it a complete square. So let us solve only the first integral, okay, and see what happens. So if I write the first integral, e power iota ax mbx e power minus mbx square by 2 kt dvx equal to, can I write it as e power minus m by 2 kt vx square? And then of course I can write, because it is a minus sign, minus iota ax vx kt along with the factor 2 also, 2ab. So 2 into vx, it means iota ax kt whole square should be added and subtracted. But first of all, write it like this. Is it okay? So now if I add and subtract a square of this term, I need to say, because this is like 2vx into iota ax kt. So from here we are getting the hint that if I add and subtract a square of this quantity, then it will become a perfect square, like this. Actually, this was in power. Let me write it in power only. This was in power along with this term. So 2vx into iota ax kt plus iota ax kt whole square minus iota ax kt whole square dvx. So minus infinity to infinity e power minus m by 2 kt vx minus iota ax kt whole square. These three terms I have combined, and then this will be e power m by 2 kt iota ax kt whole square. Minus minus becomes plus. Now this term, it is independent of vx. Now this can be taken out of the integral sign, and this will become e power minus m by 2 kt ax square k square t square. Vx minus iota ax kt whole square. Now this is exactly like that expression. Now you can make use of that shortcut formula. So this kt will get cancelled. So m ax square by 2 kt. This is the factor. And what is the value of this integral? Now you will tell me. Please check it out. You will get 2 pi kt by m square root with the help of that shortcut formula. Because even if you put this quantity equal to something like z, this will become dz. So consider it like z square, and this becomes dz. And this is the factor accompanying that z square. Okay, got this or not? Please tell.
सर उसमें भी तो होता है
What b?
velocity v power में into e power minus mv square upon 2kt.
So here you can consider the power as 0, na? That is up to you. If
Yes,
b
sir.
term is not there, it means b power 0 is there, na? So accordingly solve it.
Okay, sir.
Yes, sir.
First of all, it is an even function. Let me write that formula. It was like this, na? Minus infinity to infinity v power a e power minus mv square by 2 kt equal to 2 kt by m power a plus 1 by 2 gamma a plus 1 by 2. This, na?
Yes, sir. I got it.
So now here v power 0 is there, so it means a is 0. So in our case, a is 0, and rest everything is same. So it will become 2 kt by m square root, and gamma half. Gamma half is root pi, na?
Yes, sir.
So 2 kt by m square root into root pi. So this, na? Clear now?
Yes, sir.
And if someone is still confused, you can put this factor equal to something. If you think that here it is not same as the used one, so you can put vx equal to vx minus iota ex kt equal to t, then dvx will become dt. Okay, so you can add one more step. So it will become minus m by 2 kt small t square into dt. So then it will become exactly similar to this one. Okay, clear? So it means these two integrals, they will also assume the similar values. So it means along with this term, we are having three terms like this. Okay, the only difference is in the terms related to y, vy and vz, this ax will be replaced by ay and az respectively. That will be the only change. Na? Please check everyone.
Yes, sir.
Okay, so take care of this fact. So it means average of e power iota a dot p, it will be m by 2 pi kt 3 by 2 e power minus mex square kt by 2. This term will appear 3 times. Na? Yes, Divya, you are right. So now these three terms, they can be combined. Okay, and you can see these two factors, they are cancelling out. Na? Please check this one.
Yes, sir.
And we can combine these three exponential terms like this, na? And this will become a square. Na? So this is the answer, and this is option C. You can check. Please check everyone.
सर अपॉन में पीवी डीवी तो नहीं होता सर
क्या
अपॉन में पीवी डीवी एवरेज निकालने के लिए
नहीं होगा बेटा. Again, I explained in the beginning, and you are again asking the same question to me. मैंने पहले ही explain किया है, तो कहाँ ध्यान कहाँ है आपका? मैंने क्या बोला है कि मैं ये expression use कर रहा हूँ. नॉर्मलाइज अगर आप पीवी डिनोमिनेटर में लगाएंगे तो वो 1 ही रहेगा आपका. आप करके देख लीजिए. वो तब होता है जब आप ये नहीं यूज करते हैं कांस्टेंट फैक्टर. ट्राई टू बी अटेंटिव इन द क्लास. अगर आप इसको ड्रॉप आउट करेंगे, then you need to use, because you are not sure about the constant factor. Right now I'm using the normalized expression. I'm taking care of all the constant factors. So that's why I'm not using that term in the denominator, because that way it will become complicated. I'm already having a lengthy expression. So I have taken care of this constant factor. So no need to write that factor in the denominator, PV/dV integral, because that will give you one only in this case. If you are using the normalized one, of course, if you are not using, then you have to. Okay. Now, next one. Consider a classical gas in thermal equilibrium now T1 is less than T2. Okay, So which of the following So again, you have to find out the qualitative behavior of the probability density function. Please note down. Another two graphs are there.
Noted, sir.
Obviously, here they are plotting Vx. It is Pvx versus Vx.
Noted.
Very good, Divya. Very good, Abhay, Sanju. Yes, Kapil, good. Very good, Siddesh, Rishta. Yes, Rita, it's correct. Very good, Usman. So it's option C clearly because it is 1D case. Because they are asking you about the x component of the velocity. It means it is 1D case. And for 1D case, the graph are like this. Obviously, we have not seen graph like this and this. We have seen the graph of this kind, that is A, and then C. And then there was another kind of graph similar to A, but that was linear over here for 2D case. Remember?
Yes, sir. Yes, sir.
So B and D, they were clearly wrong. So option C, because it was 1D case. Clear?
Yes, sir.
So now let us start with thermodynamics. Obviously, when we move ahead, that thermodynamic part that will get combined again with something related to gases, in which we will study about the real gas also and critical constants of the gas, of course, critical temperature, pressure. But right now, first of all, in order to understand those quantities, we must have idea about the thermodynamic quantities, because this pressure, temperature, entropy, all these are thermodynamic quantities. Okay, so that's why now we are studying thermodynamics first. Okay, so thermodynamics. So what do we mean by thermodynamics?
Motion of heat or temperature.
Study of heat, not motion of heat. Thermo means heat. So when we study about heat, work, energy, and changes they produce in the system, that is called thermodynamics. Okay, so study of heat, work, energy, and the changes. Or it is a branch related to study whatever you want to write. Okay. Now, what do we mean by system? We said na state of the system. So what do we mean by system? System means something that we are studying. Okay, suppose I'm measuring the temperature of a glass of water. So then that water inside that glass, it is a system for me. Okay, so it is a part of universe. Obviously, it is a part of the universe which is under study. A part of the universe which is under study. Open system. Open system. So there are various kinds of systems. So open means in which we can add something. You can add some matter or you can take out something from that system. And obviously heat will also come out of that system. And heat can also enter into that system if that is cold with respect to its surroundings. So when both matter and heat, they can be exchanged between the system and the surroundings, then that system, it is called open system. Okay, so the system which is capable of exchanging okay. And another kind of system is called closed system. So in closed system, exchange of matter is not possible, but heat can come out or it can go inside. So heat can be exchanged in case of a closed system. For example, even if you cover glass of lukewarm water with something, so if you check the temperature of that glass of water after half an hour or 1 hour, you will see that the temperature of the glass of water, it will be less as compared to earlier. So this signifies that the heat is exchanged between the closed system and the surroundings. Okay. And the third type of system is isolated, which is neither capable of exchanging matter and no heat. So no transfer of isolated means akela. Okay. So no transfer of matter or energy alone between system and surroundings. Here?
Yes.
Now, there are various laws of thermodynamics, and the basic and the first of them is zeroth law. Can you tell me why it is called zeroth law? Why not first? Because
Because it was introduced before, after the first law.
yes, very much correct. Because it was discovered after the first law. So that's why they were not having any other option than to name it the zeroth law of thermodynamics. That is the reason. So it says that if a body A is in thermodynamic equilibrium with body B, and body C is also in thermodynamic equilibrium with body B, then A and C will also be in thermodynamic equilibrium with each other. Okay. So two systems which are in thermal equilibrium with a third system will also be in it means if A, it is in thermodynamic equilibrium with B, and there is a system C which is also in thermodynamic equilibrium with B, then A and C, they will also be in thermal equilibrium with each other. It's like this. Means when we are saying that A and B are in thermal equilibrium, they both are having same temperature. And when we are saying B and C are in thermal equilibrium, they both have same temperature. And now you can see the temperature of A and C is also same now. It is T for both. So obviously they will also be in thermal equilibrium with each other. Thermal equilibrium means no heat will flow between the two systems. Both are at same temperature because the heat only flows when temperature difference is there between the two systems. One is at higher temperature and the other is at low temperature. Okay. If there is no temperature difference, no heat flow. Thermodynamic properties. So there are two kinds of thermodynamic properties, which first of them are extensive and then are intensive. Extensive properties, they are dependent upon the size of the system. For example, volume. They do not depend. Density and pressure. Density and pressure. And other also, which do not depend upon the size.
Excuse me, sir.
Yes,
Sir, if we increase the size of the system, then the density will decrease.
density will.
Decrease.
What?
Because the molecules will try to spread evenly in the container. Then
So according to you, then the pressure will also decrease. If you think about, you will say even the pressure will change. If the molecules, they will distribute them like that, then the pressure will also reduce according to V, isn't it?
Yes, sir.
It's not like that. Because density, it is the ratio of two things, mass and volume. Pressure is also not directly measured. You will see later on. Okay, then you will better understand this concept, that why I have written these quantities are intensity. Okay.
Okay, sir.
So these are the ratio actually. And density of any system. Okay, I will tell you later on with the help of example when we discuss the questions. First law of thermodynamics. This was just the raw definition, and it helps in identifying the various quantities. But of course, you need to remember them. So first law of thermodynamics. So it is merely based on law of conservation of energy. This is nothing but law of conservation of energy written in the mathematical format. And it is written as dq equal to du plus dw. And this dw, it is taken as pdv. And for this, there are certain sign conventions. Sign conventions. So work done by the system is taken as positive. Work done by the system is taken as positive, while that done on the system is taken as a negative. Heat gained by the system is taken as positive, while heat lost by the system is taken as negative. Now, what about du? So first point is about the sign of dw, second point is about the sign of dq, and now the third point is about the sign of du. Du is the internal energy, and du is the change in internal energy. Okay, so if internal energy increases, it is represented by the positive sign, and if it decreases, then it is represented by the negative sign. Okay, so increase in internal energy of the system is taken as positive, while a decrease in internal energy is taken as negative. Clear? So you need to know about these sign conventions. Done, everyone?
Yes, sir. Yes, sir.
So now there are two specific heats of a gas now, which we have been calculating in kinetic theory of gases. Cv del Q by del T. So it is del U by del T. Why? Because del Q is del U plus del W, and del W is P del V. And because this is the specific heat at constant volume, so del V is 0. So that's how del Q is equal to del U. Okay. And now Cp del Q by del T at constant pressure. So it is del U plus P del V now. Because now del V is not 0. Because now the process is being carried at constant pressure rather than constant volume. So this expression, it can be split up into two expressions like this. Okay. And this is what? Del U by del T is what? Cp. So can I write it as curly V by curly T? Number 2. Now for 1 mole of an ideal gas, we know that PV is equal to RT. So I'm dropping a factor of n because I'm considering 1 mole only. So for 1 mole, it is PV equal to RT. So this gives V equal to RT by P. So it means curly V by curly T will be R by P. So now can I substitute this value over here? Okay. So substituting 3 in 2, we get the value of curly V by curly T from 3. We get Cp equal to Cv plus P into R by P. So it is Cv plus R, number 4. Or you can write Cp minus Cv equal to R. You can call it number 4. And we already know that gamma is Cp by Cv. Clear?
Yes, sir.
That's how it comes. But this is specifically valid for 1 mole. Now, isothermal process. Isothermal means temperature is constant. The process which is carried out at constant temperature is called isothermal process. And now we have to derive the expressions for work done for various thermodynamic processes. Okay. So work done is PdV integral from initial state to final state. And now volume is changing. So it will be like Vi to Vf. So let us change this P pressure into volume. How? Because PV equal to RT. So this gives us P equal to RT by V. So RT by V dV. So it is like RT dV by V. So RT, it becomes log V. RT log natural Vf by Vh. So this you need to remember. And obviously, if you want, you can replace this by PV. Okay, so it depends upon the problem at hand, whether you are being given the values of P and V or R and T. Okay, so accordingly you can modify. Now, adiabatic. Yes, this is for 1 mole. That's why I'm using PV equal to RT only. Otherwise, it would have been PV equal to nRT. Okay, for 1 mole only. Adiabatic. Adiabatic process which is carried out at constant heat means the dq is 0. Heat is constant or dq is 0. So again, PdV. For adiabatic, do you know PV gamma equal to constant? This is the equation.
Yes, sir.
So P is K by V gamma. So again, we are able to convert the expression in the form of volume. So K, V minus gamma dV. So V minus gamma plus 1 minus gamma plus 1 Vi to Vf. So K by 1 minus gamma, Vf 1 minus gamma, V initial 1 minus gamma. So this is first kind of expression. So obviously we can convert this in the P and V format also and P and T format also. Let me tell you how. So if I carry out this K term in within this bracket, then it will become KVF 1 minus gamma, KVI 1 minus gamma. It's like that. Huh? So then I can separate this into 2 parts. KVF by Vf power gamma and K by V power gamma. That can be written as P. Na? So it becomes, see here, 1 by 1 minus gamma, KVF 1 minus gamma, KVI 1 minus gamma. So it is 1 by 1 minus gamma, KVF by Vf power gamma, KVI by Vi power gamma. So can I write this term as pressure now? Final pressure. And similarly, this term as initial pressure because K by V power gamma is pressure. Na? Please check it here. Okay? Clear or not?
Clear, sir.
So now obviously, for an ideal gas, for 1 mole obviously, for 1 mole of an ideal gas, we have PV equal to RT. So we can write it as 1 by 1 minus gamma. Can I write it as RTF minus RTI? PF VF will become RTF. Na? Let me write
Yes,
it.
sir.
And
Yes, sir.
PI VI will become RTI. Na? So now you can take this R as common. So this is the third kind of expression. Clear?
Yes, sir. Yes, sir.
So now let us make a comparison between PV diagrams of isothermal and adiabatic processes. Okay. PV diagram is when we plot pressure versus volume. So comparison of slopes of isothermal and adiabatic processes. First of all, for isothermal PV equal to RT, this gives P equal to RT by V, where temperature is constant. So slope means when we make a plot between one variable and other variable, we plot one variable on x-axis and other on y-axis. Okay. So any curve between P and V, it is called PV indicator diagram. Do you remember?
Yes, sir.
You have been calling this as PV indicator diagram. Na? It may be of any shape. Okay, just for formality, I have drawn one line. So obviously, this line has some slope associated with it, na? And that slope is given by derivative of y with respect to x. Na? It is dy by dx. Na? So on y-axis we are plotting pressure, and on x-axis we are plotting volume. So that's why it is curly P by curly V. So curly P by curly V for isothermal process, it can be obtained using this expression, because now we are having P dependent upon velocity and R and T are constant. So it will become minus RT by V square. So can I write RT by V again as P? So it is nothing but minus P by V. Please check. Because RT by V is P, na? Okay, let me write one more step. RT by V, 1 by V. Now, okay. And this is negative. So it is very much clear from the diagram also. That's why I made the diagram like this, not like this. So it is decreasing, not increasing. So that's why negative sign is there. It means with increase in volume, pressure is decreasing. That's why this is having negative sign. Okay. That is with increase in volume. Obviously, this should be, because we are assuming that these are ideal one. We are doing it for ideal gas, and clearly pressure is inversely proportional to volume. So this should be. So I'm telling you the indication of this negative sign. Okay, this negative sign indicates that with increase in volume, pressure decreases. Negative sign indicates that. Okay. Now adiabatic. Adiabatic. For adiabatic, PV gamma is constant. So P is K by V gamma. K V power minus gamma. So curly P by curly V, adiabatic. It is K minus gamma. Gamma K by V power gamma plus 1. Gamma K by, can I write it as, so now again K by V gamma, it will become P, na? So it is gamma P by V. That is gamma into curly P by curly V isothermal, isn't it? Because minus P by V is slope of isothermal. Na? So slope of adiabatic curve, it is gamma times slope of isothermal curve. And we know that gamma is always greater than 1. It means slope of adiabatic curve, it is always greater than the slope of isothermal. Okay? Clear?
Yes, sir.
And now let me indicate both the processes on the same PV indicator diagram. So we know that gamma is always greater than 1. So therefore, curly P by curly V adiabatic, it is greater than curly P by curly V isothermal. Okay. So now it means if I indicate both the diagrams on the same indicator diagram like this. So the one, suppose this process is A, this is B. The one which is having more slope, it is adiabatic, and the other one which is having less slope, it is called isothermal. So obviously this is isothermal because this is less steeper, and this is adiabatic. Okay. Clear?
Yes, sir.
Yes, sir.
Now let us discuss one question based on these processes. Simple question. The nozzle of a bicycle is blocked on the handle. The pump contains a volume now the handle is pushed down with a constant force of magnitude F, reducing the volume to half. Compute the final temperature of the air in the pump.
So nozzle means
Nozzle in which you blow the air to pump the bicycle. The one with which you attach the pump like this shape. Na? This is the bicycle, and this shape part is there, na? That you normally see coming out of the tire. That is called nozzle, and you will attach the pump along with this, and then you pump the air. Okay, like this. You press this piston, and it will blow the air into the bicycle and the tire. Okay. Clear?
Okay.
That is called nozzle. Actually, the function of that nozzle is it remains blocked when you are not blowing the air in. Okay, so that the air from the tire it does not come out. But when you blow the air from outside, it gets opened and the air is able to enter inside. But the air it is not capable of coming out because of that nozzle. Yes, sir. Very good. Now let us see how we have to solve this. So clearly they have given us the indication that the process is adiabatic and volume is getting reduced to half. And we have to calculate the final temperature. Okay. Isn't it? Because for adiabatic PV gamma equal to constant. So can I write Vf as V by 2, Vi by 2, or simply V by 2, and let us write it as V power gamma because initial volume is V. Okay. Clear? Or I think you can make use of Vt expression clearly. That will be more advantageous here. TV gamma minus 1. Can I use it straight away? Do you know about this formula also for adiabatic?
Yes, sir.
Because we have knowledge about the volume, how the final and initial volumes they are connected, and we have to find the final temperature, and initial temperature is given. So Ti, initial volume is V. Final we have to calculate. This final volume is V by 2, isn't it? So Tf is equal to Ti, V by 2 power gamma minus 1, isn't it? So V and V will get cancelled now. So it will be 2 power. So it is like Ti into 2 power. Now substitute the values. This is 300 Kelvin and gamma is 1.4 now. So 300 Kelvin into 2 power 0.4. So can you get me this value now? 395.8. Please check everyone.
Yes, sir.
So what have you learned from this question? It means when the process is carried out adiabatically and you are compressing the system, here you are compressing the gas and the temperature, it rises. Okay, so that is in adiabatic compression. Temperature rises or heat is produced. Clear? And it means in adiabatic expansion, the temperature will fall. It will be the reverse. Clear?
Okay, sir.
So that's all for today, students. So we will continue from here tomorrow. So again, happy Janmashtami to all of you. Okay, bye bye. Take care.
Okay, sir. You too. Thank you, sir.
Thank you, sir.